Operation on tuples II in Python is a concept that's often overshadowed by list operations, which are typically more frequently used. However, understanding how to work with tuples can be incredibly beneficial, especially when dealing with fixed data sets. Since tuples are immutable, they lend themselves to being used as keys in dictionaries or elements in sets where you need a static and hashable collection of items. But let me assure you, the operations you can perform on tuples in Python actually offer a substantial amount of versatility and utility. Let's start with the basics of working with tuples. Accessing elements is a breeze. Imagine having a tuple representing coordinates on a map. Accessing the x value to get the longitude, for instance, isn't much different from accessing items in a list. Now, when you join two tuples, it's like you are bringing two teams together. You are adding one team's players to another's. Use the plus operator, and poof, you've got a team of elements. Concatenation works similarly. But Python is smart. It knows when to use the correct operator. If you are adding elements like appending to a list, you'd use the plus, but if you are just dealing with tuples, it defaults to making a copy of both tuples and sticking them together in order, like a neatly packed, immutable luggage. Repetition is as simple as wishing for a favorite dish. Use asterisk to make a tuple with more copies of the same element, like saying 3 times chocolate ice cream. Indexing is your friend when dealing with individual tuple elements. Remember that Python counts from 0, so accessing the second element gives you an incredibly straightforward tuple. Slicing is like cutting a cake with the operator. It lets you get any contiguous piece of the tuple, say from element A to C. This is handy when you don't need the entire tuple but a specific segment. Conversion into lists or strings, though, is where tuples truly shine. Consider a tuple of numbers that represent scores. Converting to a list allows for easy manipulation of these scores, and converting to a string lets you neatly output them into a report. When you join tuples, the newborn tuple inherits the parent's hash and can take part in the world of hash-based collections. Tuples have a built-in method called count, which, when you provide an element, returns the number of times it appears in your tuple. It's like asking how many times this word pops up across a document. Then you have a specialized method named index, which locates the first given element's first appearance. It's like marking the first mention of a character in a novel. To find the max or min, imagine them looking for the boss or hero of a movie from a tuple of characters. The in keyword isn't exclusive to tuples. You can determine the presence of an element with ease. This is a fundamental search operation, no less powerful with tuples. Creating a range of numbers with range is efficient, while ensuring that if the end value comes first, the start value is provided instead. It's the Pythonic way to count down or up to a boundary. Another tuple of numbers can represent the height and weight of people. To find the tallest person, max comes through with a swift conclusion. When you need to organize and transform these height and weight figures, zip and list comprehension come to your aid, creating a list of tuples with each person's name and corresponding height in inches, for instance, after you calculate the height in inches from centimeters. To iterate over a tuple, a looping mechanism is essential. The iter function transforms the entire tuple into an iterator, offering a more memory-efficient way to work through it. For even simpler iteration, a single line for loop directly consumes the tuple elements. Tuples also excel in maintaining order among immutable data collections. Using a tuple guarantees the order you place items in remains unaltered. Mutability isn't an option. but that doesn't mean tuples can't be dynamic in their own way. They're unchangeable, but once you create them, they represent a certain state of mind, a fixed point in your program. When it comes to assigning tuples across variables or unpacking them, Python's syntax is as elegant as it is effective. The equal signs pair with tuples in a way that assigns them without the variables being interchangeable. Tuples come with their own unique methods for getting a sneak peek into their contents or finding their boundaries, lay, max, min, index, and count. While they may not be as versatile as the list methods, they fulfill their designated roles remarkably well. Tuples are more than just a simple container, they're a testament to Python's efficiency and design philosophy. As you progress, using tuples where immutability is a must, like with file paths or fixed data sets, will make your code cleaner and, in some cases, more performant. Now, as a Python enthusiast, you are well on your way to becoming a more proficient coder. Tuples may seem less prominent, but as they say, the devil is in the details, and these operations offer subtle efficiencies and reliability that enhance coding practices significantly. So if you liked this tutorial and you are keen on mastering tuples, subscribe and learn more. You'll find plenty of resources and further learning opportunities at TechLab, always keeping you updated with the latest Python techniques and best practices. And remember, the only thing faster might be learning a whole new language, so why not stick with Python, the language we all love? Visit Neeraj's website at qzz.io, and don't forget to subscribe to TechLab to stay informed on all things tech.